Okay. Hi, I'm Long. Today I will do a mock interview with you. So can you tell me about yourself?
Sure. Hi, so I'm Aditya. I'm currently an applied scientist at Amazon, where I primarily work on using deep learning models to detect user fraud in Amazon advertising. Typically, Amazon receives about a billion clicks plus a week, and these come from millions of user accounts and several million user agents and IP addresses. Our goal is to use deep learning models. My work focuses on graph neural networks to mine patterns out of these and to detect groups of collusive users who are robotic. Typically, this fraud is conducted with an intent to either remove revenue from competing advertisers or to re-rank your own product up. So basically, to game the system. So typically, we train our models to detect such patterns, find the groups of anomalous users, and remove them from the Amazon advertising system, keeping it healthy.
I see. It's like a very big system, right? And so
Yep.
can you tell me more about this is kind of data pipeline and you extract the data from the system?
Right. So typically, we have teams at Amazon that focus on collecting the data and making sure it's consistent. So typically, this is fed in as input to our algorithms. My role is typically to start with raw data sets where typically you get entity at a click granularity or a ad view granularity, and then
Uh,
first write big data, basically PySpark code to aggregate and compute meaningful features corresponding to each entity I want to model. So typically, like I would collect IP specific features, user agent specific features. These
okay.
are going to be correct.
Okay. Oh, what about tech stack? So tech
So,
stack you are using?
typically, the ETL side of things, I may mostly use PySpark and SQL. On
Uh,
the machine learning side, I focus on mostly PyTorch, but at the same time, I'm proficient in TensorFlow and Keras as well.
okay, great. Okay, before we jump into the coding round first, I will ask you about some CS knowledge first, okay?
Sure.
Uh, can, okay, tell me about the process and thread.
Sorry.
Tell me about the process and thread. You can compare them. Thread and process.
Um, I, I didn't get the word you were saying. Sorry.
Okay, I mean, can you compare the thread and process? I can tell out here. Thread and process.
Thread and process. Got it.
Yeah,
So
yeah.
typically, a single thread is going to be associated with. So currently we work with multi-core systems, and each can have multiple threads. So a thread is a single sort of logical execution unit. So today's processors can have like parallelly 8 threads running, 16 threads running, so on. A process can execute across multiple threads,
Ah,
but it
yeah.
requires at least one thread at the minimum.
Okay, okay, cool. And you know geolog in Python? Geolog?
Gillog would be basically the restriction of the main process to run on a thread. I mean, I'm not familiar with too much of the details, but this prevents multiprocessing from being executed in a distributed fashion.
Yeah, this is very famous in Python. Yeah, okay.
Yeah,
Uh, okay, I think it's enough. Can you share screen? You can use any ID. Uh,
sure.
yeah.
Uh, I guess.
I think for this role, I will test you with Python first, all right? You need to write code in Python. Okay?
Okay, got it. Could we use Colab? I guess, or I mean, do we need? I can open up something on VS Code either.
Okay, any,
Okay.
any, no worry. As long as I can see your screen, it's okay.
Got it. I think this would be. Let me just open a new.
You are using Python 2 or 3?
I'll be using Python 3.
Python 3. Same,
Okay, yeah.
same here, same here.
Yep.
Okay,
Okay, so I guess this is where I'll code if that's okay.
can we start? Okay,
Yeah,
ready?
sure. Yep.
Okay, I will give you a linked list. You need to reverse the linked list. Okay.
Okay. In that case, could I use C++ if that's okay?
Okay, it's okay.
All right. I'll
If
just
you want.
swap it. Maybe. You can see. I just opened a text editor, or I mean, let me just open VS Code if that's okay.
Okay.
I'll just create a new directory. Uh, in the real interview, will this be in like a proper IDE, or is it going to be like sort of share screen and do it on the fly?
Okay. Code. You are using Visual Code.
Yeah.
Okay. So yeah, we have a linked list, singly linked list. Okay. And you need to revert it.
Okay. Well, Uh, sorry, I'm just having a bit technical snag. Okay.
Okay. It work, it
Uh,
work.
yeah. Is there any input format that I'm given? Like, what is the structure of the node?
Okay. Each node contain only the integer at a value. So it's okay.
Okay. So, could you provide me a structure? So something like structure.
Okay. Okay.
Uh,
Struct.
if
You
you,
can use struct.
yeah, I guess. Uh,
Okay.
oh yeah,
Struct.
struct node,
Yeah.
and I'm gonna have int value,
Yeah. Value is enough. So
and then I'm gonna have something next. Star next is this fine?
okay, fine. Okay, cool. Okay.
So basically, what I have here is I'm trying to. I'm assuming that I initially have some input, and this can be something like there is
Okay.
one pointing to 3, which is pointing to 2, pointing. So let's assume
Okay.
that this is a necklace. Uh,
Yeah.
let, let me just, I guess, look at the first, handle the trivial case. So if head is null, then I just return null. So I,
Correct.
n- now basically I'm gonna have to keep track of the pointers
Oh,
going ahead. So at every point in time, I want to keep. I'll just handle a couple of trivial cases as well. So
can you explain your algorithm first?
sure.
Tell me about.
So basically, what I'm going to do is I'm going to keep track of. Just I'll just think about it for a minute.
Okay. No worry.
Okay, so I basically want to keep track of three different pointers at every point
Yeah.
in time. So first, I will handle the trivial cases. So the trivial case is when I get a null or an empty linked list, the case where I get a linked list of length 1 or length 2. Now, those cases I can just manually handle them and pass it. Now, so basically, if I get an empty linked list, I'll just return null. If I get a single linked list, I'll return the same value. If I get a linked list of length 2, I basically return. I will first take head. I will store head dot next, and then I will change the point. Basically, I'll make head point to null, and then head dot next point to head and return.
Ah,
Basically head dot.
I
From
see.
three from three onwards, what I want to do is I need to basically run a loop, and at every point I want the mid node. Basically, let's suppose I have node dot next, and node dot next dot next. Basically, I want node dot next to point to node, and then basically I want to preserve the chain. So as long as I have three pointers, I can always keep track of what element I need to reverse, what element I should make the current element point to, and so on. And I'll just loop through the whole list.
Okay. Can you do it with your example? I think with your algorithm. Okay.
Okay,
Can you show
so
me? Yeah.
should I code it, or I guess a dry run would be.
Yeah. Okay. You
Uh,
can
l-
run algorithm with this example, and
okay,
it's
so
more
basically,
clear. Yeah.
so I'm gonna keep track of one, and then I'm
Yeah.
gonna. So basically, let's just call this temp one. The temp two is equal to one dot next, uh, which is equal to two,
Oh.
and temp three. I mean, I will be implementing it as well. Just
Yeah. No need to more detail. No need more detail. No need detail.
okay.
I mean, I just yeah. Okay. Okay. Let's start to implement. So I can understand. Oh. You are using recursion, right? I guess.
No, no. I'll run it as a for loop at the end. Basically,
Okay.
just handling the edge cases.
Okay, okay.
Now, from now I can start. So basically, uh,
Okay. You declare three. Okay.
temp three not equal to null. So mm,
Ten. Can you say something? Okay.
yeah, yeah. So from this point onwards, what I'm doing is first I just make the head node point to null. I'm gonna say temp two dot next is equal to temp one. So I am reversing the links for the middle node on the chain, and
Yeah.
then I'm basically gonna do temp one is equal to temp two. So now I
Okay.
have reversed one portion of the chain. Uh, temp three.
Ah, okay.
I'll just sort of make sure the logic works.
Uh, your algorithm is I can understand your algorithm. And so we have a three pointer, so we try to revert the pointer to point to the previous node, right? Whatever is
Right.
it like, yeah, is it like with this information? I'm not sure. I'm not sure it's work or not.
Uh, I'm trying to make sure I don't miss anything.
Okay.
Uh,
Let me see.
so
Tab,
temp.
whatever, yeah, what about, yeah, how you return? What is the variable you store the answer? Tab two?
So I will eventually have to
Okay,
return the temp one is equal to temp two. Temp three is equal, temp two is equal to temp three. Uh, I just need to make sure I do the swapping correctly. Just a second, I'll sort of think through it and then make the next step.
okay. Uh, tab two for your tab one.
Two is equal to, sorry, I'm getting a bit caught.
Okay, tab three, you channel. I can see.
Okay, so if I've done this, what I basically, I guess, let me try run this and make sure. So first,
Oh,
first I removed the reference of one, and initially I have temp. These are one, three, and two. Maybe I'll add a couple of chained elements. So
okay, okay.
now, so temp two dot next is equal to temp one. So what I did is I just made three 3.21, and then temp one is equal to temp two. So I I moved the first pointer to three. Temp three is equal to temp two dot next. So no, 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 no.
Yeah, it's not like we need extra variables. So.
Got it. I think. Uh, wait, no.
Okay, I will make it easier for you. First of all, like how you can deal with recursion, and how you solve it with recursion. Maybe it help you
Got it.
too.
For recursion, basically, again, I need to maintain uh, at the end of the day three different variables, and then I have to do the reversing order correctly. Uh, I think even here I'm sort of confident if I just get the right order for this loop, it will work out. So basically, I just changed this, and I still have my values for one, three, and two.
Yeah, because for the iterative, I think maybe it a little bit hard for you to implement it to implement. Maybe you can switch
Oh,
to the recursion version and yeah.
I'll just give this a shot for a couple of minutes. If this, I guess, if it doesn't work out, I'll immediately switch.
Okay. Mm,
One, temp 2 dot next equals to temp 1. Temp 1 is equal to temp 2 makes sense. Uh, temp 3, so temp 2 should be equal to temp 3. Okay, I think this. temp3 should be equal to temp3 dot next. Now, so what I've done is basically, maybe I can do a dry run here. So we initially start with this list. So 1 points to 3 points to 2 points to 4 so on. And we get the first three values as 1, 3 and 2. Now what I'm doing first is I'm making 1 point to nothing. And then I'm making temp2 point to temp1. So we reverse the first bit of the connection. Now
Yeah.
what we do is temp1 is equal to temp2. So we've got this as pointing to 3. Temp2 is equal to temp3. So uh, basically what this does is we've got this updated to 2 and temp3 is equal to temp3 dot next. So we've got this updated to 4. And now basically we go into this loop and we find that temp3 is not null. So then we go check here. Temp2 dot next is equal to temp1. So 2 dot next is equal to, we have reversed this chain part of the chain
Yeah.
success. So this will proceed sequentially and we can reverse the links up till here.
Yes. Okay.
So now we end up with a step where temp3 is let me just I guess check the last steps logic so that I figure out which pointer to return. So once we reach the last step, temp3 would have become null, so we need to return temp2.
I'm sure. Okay. I'm sure. Yeah, I can see. I can see. Okay. Can you write some test case with it and run it?
Sure.
Okay.
In the interview, am I allowed to sort of debug with an IDE? Uh, so
Oh, you can print ID. It's okay because we have value, right? You can mark it as ID also. 1, 2, 3, 4, 5.
okay. Uh,
Okay.
initially, we want so I guess uh, I'll just create it manually.
Yeah.
Normally, I write a constructor and more details, but I think we're doing it on the fly. As in
Okay.
terms of,
Yes. Uh, 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 oh.
yeah, as in I'll make sure that they point correctly at the end of it.
Okay. Okay.
Uh, Also, just to check, do I get a sort of wrapper of the initial test case, or is it like we code it on the fly in the interview?
Sorry. Can you repeat your question?
So, in the real interview, will I get something like a lead code environment where the test case is already set up, or is it usually that I have to code up the initial question as well?
Yes. For the best case, you need to finish the course and this depend on the interviewer. They can ask you to
Oh,
run or not, or can dry run. It's quite depend.
okay, okay,
So unstructured.
yeah. Uh,
Yeah.
so,
The keyword is unstructured. Maybe it's different from the Google interview. So
yeah, so I think we've got the
okay,
linked list created. So now I want to return.
okay. To print it, you can write some function to print all the value. Okay, and so just your for loop, for example.
Okay, so we're returning 5. Uh, no, so it looks like we're not returning the correct.
Uh, STDC plus plus, I don't remember, plus plus
Yeah, yeah.
equal.
So I think now we're able to compile the code. I just realized that
Uh,
there's a
uh,
small thing I need to check in my code where the last
oh,
sorry that was
oh no,
unintentional.
no.
Yeah, sorry. Yeah, is it still with me?
Ah, okay. It should like time two is near and okay, let's check.
Yes. Yes. Yeah. So we got it.
Okay. It's cool. Wow. Yeah. Okay. Next analyze your algorithm. Can you tell me about the space and time velocity?
Sure. So if at all our algorithm is if we consider the size of the linked list as n, my time complexity is O of n, and my space complexity is O of 1. So I take constant time, constant space, and linear time.
Okay. Move to the second question. Okay. I think
Sure.
it's cool. Okay. Now I give you intrinsic increasing array. So
Okay.
integer, continually integer. And so and the number x and one number x. Let's find the lattice position equal to x. The lattice position contain x in the array. Okay.
Okay. So basically, what I have is maybe a vector of int or
Okay. Vector
array,
integer.
and then I have int x, and I have to find the basically I have to find is so this is monotonic, so this is sorted.
Yeah, sorted.
Now I have to find the position of x, or
And yeah, I give you a integer x called x. Okay. And so find the lattice position. For example, like x equal to one.
how?
Okay. And we have
Okay.
one one two two one one two two. And so yeah.
How?
And so the answer here is one, right? Lattice
O-
position. So
Okay, so what would the answer
the-
be here?
yeah,
It would be this one.
yeah. Lattice
Oh,
position. So the index.
okay,
You
got it.
understand?
So yeah, so I think can I use C++ functions? I think there is a C++ lower bound or upper bound function that does it, or I can do it using binary search.
Okay, as long as you can explain how it works. So
Okay,
can you tell
so
me about the algorithm first? Because
sure.
you are using a library, right? Tell me about the algorithm first.
Sure, sounds good. So basically, the since we have a sorted array, we can do binary search. So the way binary search will work is initially we take the starting point of our search to be the zeroth position and the last position of the array. So we start out with 0 comma 3 as like our starting search point for the algorithm, and at every point we look at the mid of the basically the central value among these. So we can just do 0 plus 3 divided by 2, which would give us 1 as an integer. And what we do is we always query and check whether the value that we get for the mid value is greater than or equal to this current value. If yes, we basically start searching for the value within the left part of the array, or we can search for it on the right part of the array. This works because the array is sorted. So at every point we can half the size of the array effectively, and we can find out the position in log n time.
Okay, and
Uh,
space
Sorry,
space complexity. And what about
space,
space complexity?
space complexity would be constant.
Correct.
So,
And
so
what about the case if x not exist in the array?
So if x does not exist in the array, we basically have a condition that since we're tracking the left and right bounds of the array, eventually the left and right bounds will overlap. And if at all they overlap, I mean, there's going to be, we write our loop such that the the right bound is going to cross the left bound. And at that point, we stop the loop. So since we're writing it as a iterative process, our stopping condition is if at all our left and right bounds are equal and we have not found the value yet and the value is not the same as the current value of the left and the right bounds. Or we can write it such that the right bound and the left bound will cross each other if we don't find the value.
And what kind of value you will return if x not exist in the array? Okay, let's return -1 is okay.
Yeah, we
Default.
can return. Yeah,
Okay. And okay, can you code it? Code it up.
sure.
I expect. Okay.
Uh, I'll just code up this for now, but I mean, we can change the test cases according to whatever you're,
Yeah.
you'd suggest. So,
Okay, okay, no worry. Do it. So finish the code first. Okay.
oh, okay, I do not recall the syntax. Or, you know what, I'll just actually code up the whole binary search.
Okay, you can code it by yourself.
Yeah.
So
So what I'm doing is I'm just having a left, right, and mid, and at every step I do, mid is equal to left plus right minus left by 2.
okay. Mm.
The end of the loop.
Uh, the main function no return. The main function I think just print.
Yeah, yes. Sorry.
The main function. Okay, because for main function we return 0 or 1 as I remember.
Yeah, yeah, yeah.
Yeah.
So I
We,
think this should work. Now the only thing I have to make sure is that it does not end up in an infinite loop. So
sorry.
the,
Yeah,
that,
your final answer is M. Your final answer is M. Are you sure? M.
let me just check. Uh,
Okay, just confirm. I mean,
yeah, yeah. Can I run my solution as in like just to check, or would you suggest I mean, I can
because
sort of debug.
M is middle point, and I think maybe that's okay, right? M is valid or M is not valid. Not quite sure. I don't think M is the final answer. I think. Are you
Okay.
sure? Because
Yeah, yeah. I'm just thinking. If I
do
see
we
out,
need do we need another variable to store the answer? And do you think so?
I mean, I can code it up with this variable as well. So basically, what it will do is, so I mean, the only case where we end up, we don't need another variable. I can return L if at all I write the loop conditions correctly. So,
Yeah, okay.
yes. So
Okay.
basic basically, if I look at a dry run of this, I might have to try a few edge cases. Maybe I'll just add one more one for like a more clearer problem. So
Oh,
if
but
I
yeah, what about if the answer not exist? So maybe L is not valid.
got it,
L is not valid, right? For example, like if x equal to 4, and so yeah, L is not valid.
oh,
Do you need a
okay.
check?
Yeah, so if at all we never end up in this condition. So if at all, okay, so there are two possibilities. Now,
Yeah, because in the case that x is not exist in the array, and so I need you to return -1, for example, print -1. So it's like you missing this point.
got it. So maybe I will just keep an int answer kind of.
Ah,
And
okay, don't make it complicated. I think just use a check. Just use a check as the final. I think your
okay,
code is okay. Why?
okay, got it.
No need
Uh,
to complicate it. No need. No need. No need. I think. Yeah,
okay, so I think the one point. Okay, so if I have to add a check function, uh, sorry,
because
I'll just.
yeah, in the line. Let me see.
So the only point where I think we can,
As
let's suppose
uh,
let's suppose we're, so,
as the line 30, 33, I think. As the line 33, I think just one check. Just one check. Right?
uh,
If the answer don't exist, so just print -1. Very
okay.
simple.
If at all we, yeah, yeah, if left and right exceed the bound, so basically, what are the cases it can happen? So um, no, actually, I'm sorry, I got a bit confused. We can add a
Yeah.
check function.
Yeah, because I can understand your algorithm, right? Because you will store the final answer in the variable L, right?
Right.
And
So,
try to assign M in the case that the variable in the index M is still smaller or equal to X value, right? So I think it's correct. Why you need to modify it? Just only one check.
okay.
Make it simple, I think. Okay.
What are the possible edge cases? So, if at all
Oh,
the number is larger than any
okay.
possible.
You can run it first. You can run it first and see the. You can run it. Let's run it.
Project. Eh, undefined.
Yeah, copy paste. Or remove. Yeah.
Okay, so in this case, we got the right answer, which is three. Now let me
Sweet. Yeah. It's
let me,
correct, right?
yeah, let me just try this like this.
I mean, your code is correct. Just only one check. Only one check is then we can finish.
Got it. Uh, if L equals 0,
No. Not at that line. Yeah, okay. Because your
Uh,
algorithm is cooking. Your algorithm is cooking,
yeah,
but you can only one
uh,
check. Okay. Scroll
for
down,
which,
scroll down.
yeah.
You can scroll down. The code line 38. Okay, yeah, just right. Check here. In that all. Uh,
Uh,
and no. If if the
uh,
value at the if the value at index L is not equal to x, it's just print -1 is okay.
oh, okay.
You're right.
Got it. Yeah. So let me just say, I think int length is equal to r dot size minus one. If x.
Uh, oh no. Uh,
Yeah, yeah, C out minus one. Sir.
I think this check is then not enough. I think, but however, just only one check,
Uh,
only one check, only one check, only one. Just value at index L is not equal to x. That or why too complicated? No need.
okay. If the only case we have it is if at all x is greater than the last element, right? In that case, we're out of bounds. At every other place, we will have a lower bound.
Because remember that for example, like if I send you array 1, 1, 4, 4, and x equal to 3, yeah, you need to return -1 because
Oh,
we have no index. We have no index, right? Just only one check. Why you make it very complicated? I think. Yes,
yeah. Sorry about that.
yes.
I took too much time on it.
Okay.
Yeah, yeah. I think we're done. Yeah, I think
Yes,
this will be
yes, that's what I want. Okay.
awesome.
Okay. Okay. Yeah, we can. I think John is cooking, so I think we can finish. Okay.
Got
Okay,
it.
let me stop it.